Hey guys, I just want to talk to you about what we did in pre-calculus class today. Those of you who missed class today, whether you're virtual or whether you're on campus but you're not ready to be in class or you're sick or what have you, I'm going to explain to you what we did today. We talked about numbers, what types of numbers there are, and we talked about set builder notation. It's a way to describe a set. All right, a set of data, a set of numbers, and really what this fits into is functions. And we take sets of data and how they compare to another, or how we have inputs and outputs, and each set of data helps us out. We're going to talk about a domain and how that set of numbers fits into that input-output, which is a function. I'm going to describe all these numbers to you. We're not going to talk about complex numbers or imaginary numbers. I don't care about those right now. Right now I just care about all those real numbers. Every number that we understand as a number, whether it be rational or irrational, it's a real number. Rational numbers, all those numbers that can be expressed as a fraction, be it 3/7 or negative 4/9 or 83 or what have you. Those are rational numbers. They have terminating or repeating decimals, right? Irrational numbers are the opposite of that. Pi, the square root of 2, the square root of 7, other numbers just like that. You know, negative square root of 45 is an irrational number because it can't be, that square root can't be done to pull out some perfect square. Anyway, now we move to integers, which are those positive or negative whole numbers. Then we move to whole numbers, which is 0, 1, 2, 3, and all the positives infinitely, those counting numbers. Nothing in between, just those counting numbers. And then last but not least, the center of our bullseye are those natural numbers. And it's the same thing as whole numbers, except it doesn't include 0. All right, so that's really quite simple. You need to go back over the video to remind yourself of what those are. That's totally fine. Then we're going to talk about I'm going to show you how to build set builder notation. We have braces, there they are, and then we have this x with a bar. And what this says is the set of all x such that, then we have some sort of inequality. This inequality says 2 is less than or equal to x, which is less than or equal to 7. And then we're going to use this thing called the element. And we're going to say that x is an element, or x is an element of some set of numbers, some type of numbers. Okay? And then I'm going to take this inequality and I'm going to build set builder notation for you right now. Here it is. X is the set of all x such that 2 is less than or equal to x, which is less than or equal to 7. All right? And we're done. Our inequality is there. Now we're going to tell whoever is reading this what x is a set of. X is an element of, I apologize. And what do we know about all the numbers in between 2 and 7? Well, we have whole numbers in there. Could count integers in there. We have rational numbers in there because there are some fractions or decimals in there, right? But we also have some irrational numbers in there too, right? We know that in between 2 and 7, we have the square root of 27, right? And the square root of 27 is irrational. So we know that we have rational, irrational, we have everything in there, so we're going to say it's an element of real numbers. And then we're going to close it, and that's it. Okay? So that's really cool. That's pretty easy. We just sort of bring down our inequality and put it in here, and we have a way to read it. I'm going to try one of your examples. It's on your study guide sheet. Just going to erase pieces of it because they all start and end virtually the same way. This one, I'm going to put an X in here. And I'm going to talk about this set that's been given to us. It's 17, 18, 19, 20 ellipses. And the ellipses tell us that the set continues on infinitely in terms of counting numbers. And so what is this inequality? Well, we're going to talk about everything greater than or equal to 17, right? It's 17 and up. So the set of all x such that x is greater than or equal to 17. That's the end of our inequality. Where x is an element of what type of numbers are these? How specific? How close to the center of that bullseye can we get? Well, you know what? We can get to the center of it. Because these are all whole, positive counting numbers, and it doesn't include 0. So if that doesn't make sense, go back over it, try to understand what types of numbers there are, but I'm going to say that x is an element of natural numbers, of the natural numbers. All right? And so those are two types of step builder notation. And the last is going to use this symbol down here, this union symbol. When we have two separate inequalities, and you have a choice of your x's being part of one set or another, we use this union symbol, because it says it's part of one or another, and we build two set builder notations and put the union symbol in between. And I'm going to show you an example of that right now. And I'm going to need a little bit of extra space, and I know I don't have a whole lot of space to move over here, but I do have some. And I'm going to say, this is number 5 on your sheet. I'm going to say x is less than negative 11, or x is greater than or equal to 1. So I have two separate inequalities. And like I said, I'm going to put my brace in, and I'm going to say x such that x, just bring down the inequality, is less than negative 11, right? And everything less than negative 11 fits into this real number set, right? There are all sorts of types of numbers: rational, irrational, whole, integers. Well, there are no wholes or naturals because we're talking about negative numbers, but we'll get there. But it includes everything that's real. So, okay, it's an element of real numbers. Sorry about this symbol here. All right? And then we're going to write or. No, we're not. We're going to write union. Ah, the or was up top. We're going to say union. Union. And then we're going to do it again. And I'm going to try and fit it in here because I squeezed myself in. And I'm going to say x is greater than or equal to 1, where x is an element of real numbers. And I'm going to put my last brace in, and I got it. There's my union. Okay. So x could be in either one or the other sets. Great? Awesome. What I'm going to do after this, and the next video that I show, is going to explain what is called interval notation. And it's much, much simpler, but you need to understand this part before you move on to the next part. And I'm going to explain when you can use, when you're allowed to use interval notation and when you're not allowed to use interval notation. Thanks for listening.